Hi guys, today we will be discussing this problem from LeetCode, which is minimum cost climbing stairs. So it is a very basic problem of dynamic programming. It helps us to understand dynamic programming in much better way. So let's see this problem. On a staircase, the ith step has some non-negative cost of I, assigned basically zero indexed. So we are given an array whose name is cost, where each index contains a value which is basically the cost, and that too non-negative. Basically there is a difference between positive and non-negative. Positive numbers include 1 2 3 4 5 6 like this and so on, but in non-negative 0 is also included, like 0 1 2 3 4 5 6 and so on. So let's move ahead. Once you pay the cost, you can either climb one or two steps. So if we are standing on particular index, we can make like we have two options, like we can make one step ahead or two steps ahead, and you need to find the minimum cost to reach the top of the floor. We need to find the minimum cost to reach the top of the floor, and you can either start from step with index 0 or with index 1. So I hope the problem is clear. If difficulty in understanding the problem, you can pause the video and give give it one more shot. So let's understand what the problem is trying to say with some test cases. Like the problem is trying to say, like we have these are the elements of the array. So if you are standing at this particular index, you can either make a jump of 1 or you can make a jump of 2 to reach the end of the basically stairs. So, and when you jump, like have you jumped one step, then this cost will be included. And similarly, when you have jumped like this, then to this particular cost will be basically added. So let's clear this out and understand how are the things working. So like we are given in the question that we can either start from 0th index or first index. So okay, if we choose to start from 0th index, currently you are standing here, so what is the minimum cost to reach here? Since you are already standing here, so no cost is included, so but particularly here the cost will be 0 initially. Now if you have to jump to 15, like you take one step, now you have to collect 10, like 10 will be added to your cost. So basically from if you have to reach 15, from 10 you have to pay cost of 10. Similarly, you have an option to jump to 20 also. Here also you have to pay cost of 10, like this will be added. So that's the case. And if you are standing at 15, so what firstly you will find what is the cost of reaching 15. So you already have calculated it, like it is 10. Now from 15 also you have two options, like you can jump to 20. Now if you jump to 20, now the total cost for it will be basically 10, the previous one, plus the 15 itself. So you have to pay the cost of 25. Okay, so if you choose to make a step of 2, now you are on the top of the stairs, basically out of the array, so then also you have to pay 25 rupees only. But in case you are here, so what will be the question arising? So first question that will arise is, what is the cost of reaching 21st? Okay, So the cost of reaching 20 can be either 25 or it can be 10, like it was 10 when we jumped directly from 10 to 20, and it will be 25 when first we came from 10 to 15 and then from 15 to 20. So it will be, we have two costs of reaching to 20. Since we are required to find the minimum cost, so obviously we will always try to keep the cost minimum, and so we will choose this 10. Okay, so if we have chosen this 10 and now we have to take a jump of 1, now this 10 plus this 20 versus you had done 25, 25 plus 20, which is the least cost, which is the minimum cost between them, obviously this, which is 30. So now since we have reached to the end of the array, which is the end of the array, basically the top of the stairs, so when we discovered this top of the square via 20, so the minimum cost that was possible was basically 30, and if we discovered it from 15, now the minimum cost is basically 25. So yes, if we start from the first index, then what can be the minimum cost of reaching this uh, top of the stairs? It will be minimum between 25 and 30, which is 25. But can we do better? Is it possible that we can do better also? Like, can we achieve a cost less than 25 also? So let's see that test case too. So the previous time we started from the 0th index, and as you can see in the question, like here it is given, you can either start from the step with index 0 or with index 1. So last time we started with index 0, now we will start from index 1. Okay, so since we are already standing at index 1, so basically the initial cost will be obviously 0, because we are just starting from here. So now we have two options, like we can jump from here to here, and or we can go directly outside it. So aim is to get outside the array, so don't confuse yourself. So if you go from 15 to 20, then here the cost will be 15 to reach the 20, and then further 20 will take another jump, which will be 15 plus 20, 15 plus 20. Okay, but we have another option also, we can directly jump outside the array, so here the cost will be 15. So if we are standing at first index, this first index, what will be the minimum cost of reaching outside this array? It will be basically 15 plus 20 versus this 15, which is obviously minimum 15. Now we had two options, either we could start from 0th index or first index. So in the case we started with 0th index, what was the minimum answer? It was 25. And when we started from basically first index, then the answer is 15. So which of them will contribute to our answer? Obviously the minimum one. So yes, 15 is our answer, since we can verify also. 15 is our answer. We will understand one more test case like this one. So let me clear some things of the screen. So yes, Now it can come to our mind like, is it necessary to like take one jump? We can just go with two, like in this test case. If you think like you will go from here to here, two steps, and again two steps, again two steps, but here here this will increase your answer. So what can be done like this? We can go from the here to here, now from here, and this and this, basically 1 2 3 4 5 6 plus this one 7, oh 6, sorry 6, basically initially it was 0, so yes, of reaching here 1 2 3 4 5 and here 6, yes. So yes, we have to choose, we have to explore all the possible conditions that we can. So yes, we will be discussing this test case. Like if we start from here, we can go up till here. Here it will take a cost of 1. To reach here it will take a cost of 1. If we come here, then it will take a cost of 1 again. Now again we have option, we can go from here to here. Now it will take a cost of 100. So which is better, 100 versus 1? It is obviously 1. So we will never make this jump. Or we can try this one also. Again here it will be 100, but we can also reach here from this particular position, so it will be 1 versus plus this one, which will be 2. So likewise we have to see what all possibilities are possible. So let's code this up and you will get a better understanding. So okay, so firstly I will do a recursive solution. So the basic, very recursive, the basics approach that can come to your mind. My this function will return the minimum steps that are required to reach out of that array. So basically it will be function, and I will take a cost array which will help me to remember the costs. And yes, another thing that we are required to label a position. We are required a position currently we are standing at. So now what we can do, firstly I will initialize variable n equal to cost dot length, which is equal to length of the cost. So what else is required? Now we have two options, from any index. We have either we can jump to +1 or +2. So if it is possible to jump on +1, like position +1 is less than n, then we can call a function cost, and we can increase the position by 1, and we have to store the answer also. We will make two variables, a and b, both initialized to maximum. So yes, a will be this, if position +2 is less than n. What we are required to do, we are required to make it jump to position +2, position +2. Yes. So now what we have to return, we have basically, here we have not included the prices, I forgot that. we also have to include the basically cost of this particular position. I'll explain this. Why are we doing this? Cost of this particular position. Yes. Basically, if you are standing at this particular index, and let's say of reaching here, the previous cost was X. Okay. So now if you are jumping from taking one jump, then the cost will be X plus 100. X plus 100. Similarly, for two jumps, it will be similar X plus 100. So yes, so that's why we have to include the price of this particular position too. So that's what we are doing here and here. So now we can just return the minimum, basically minimum of A and B. Why the minimum? Because basically we require the minimum cost. So yes, that is it. We can return a function and we can parse cost, and since we were starting from 0, now here are two things, like here we are taking case like if we started from 0, but we can also start from 1. So what is required is we can similarly make, and we can minimize this answer. Basically we starting from 1. So what I have done this, let me tell you, like previously what we did was in this case, like we started from 0, and in the second case we started from 1. So in the case we started from 0, the minimum answer was 25. Okay, so the case we started from first index, the answer was 15. So that's what we are doing, so we have to take the minimum of them. So yes, I think the code should work. Okay, so since we are given non-negative cost, so like for example we are not able to take a jump further, so what we are required to do is that, okay, so obviously these both will be initialized with plus infinity, so we need to see that case also, like if a is equal to plus infinity, then we will make a 0. Okay, and p equal to, similarly b, for b we will make it 0. Let's see if our code is working. Let's try to submit it. So yes, uh, what we are missing here is, like we are just considering the cost to reach up till here, but we have to go outside this array, like this price will also be included. Why we are getting 0? Like if we started from 0, then let me explain this test case why we are getting wrong answer. Yes, so basically what we are doing is, like we jumped from here to here, so the price will be 0. We jumped from here to here, price will again be 0 of reaching here. So we are just taking price to reach at till this point. Okay, similarly at this point, but we need to go outside the array, so we need to put another another thing also, like else case. What if we are not able to jump outside this array, like position plus 1 is less than 0, else what we have to do? A is equal to cost of that particular position. Similarly for B, I'll explain what we are doing. So basically after like reaching at this point, now since we cannot take another jump as it will give an exception, so what we are doing is, like, we are not calling the function again, so we are just adding this price to our previous answer. Like previous answer was x up till reaching here, so we are just making x plus 1. And for similarly for this, and we are taking, just if it was y, then y plus 100. So we will find the minimum between them. So I think now it should work. Let's try it. Yes, it is working, but now we are getting time limit exceeded. So let's analyze our code, why we are getting time limit exceeded. Since we did a recursive solution, so obviously we had two options every time we had two options. Like if you are standing here, you can go till here, here, and if you are standing here at this particular position, you can go up from here to here. So every time if there are n elements in an array, or n positions, or n stairs, so for each stair you have two two options. So similarly for this also, two options, two options, two options. So total number of permutations will be basically 2 to the power n, which is very high. Like for, if you check for only 10 elements, it will be 1024 operations, and if it comes out to be like 15, 20, it will go way up. So that is the reason we are getting time limit exceeded. And you know that in 1 second we can just perform 10 to the power approximately 9 operations. So that is the reason we are getting time limit exceeded. What can we do? Like we can, since we are computing many states again and again, like if you have reached here, so it is again exploring, this person is again exploring to how, which is the best possible to reach here. So again and again the things are being computed, so we can store them in a dp array. So we will make a dp array. Now one more key point here is, like, how to know should we make it 1D dp array or 2D dp array. So I'll tell you how to figure this thing out. So if you ever have to find out, like you have to make 1D or 2D or 3D, any or multi-dimensional, so how will you come to know? You just need to find the states on which your answer is depending. Like in this question, our answer is only depending on the particular position we are standing on. So that is the reason, since the state is only single, basically one, so we need 1D dp array. If there were more than two states involved, like the answer depended on two conditions, so, or two states, so then we had to make 2D dp array. So that is one more thing. Now we can parse our dp array here and here also, and yes, now we will apply the condition for dynamic programming here. if dp of particular position has already been calculated, so it basically which is not equal to 0, what we have to do, we have to return the already computed answer for that particular position. So we have to make changes here too, like dp, and we have to store our minimum in dp of position. So I think now it should work. So let's see. position. Okay, so error in spellings. Yes, now it is working. So this is called the top down approach, where you are just parsing the dp array in the recursion. So now we will learn bottom up approach, basically where we are building our answer like in tabulation form. From small to higher we are building our answer. So let's reset our code. Yes, I want to reset. Now what let me explain you what we will be going to do. We will just, like, this is our array, then these are the indices. So what we will be doing, like if we consider for this particular index, like this particular index, what all options are available to it, like it can jump from here to here or from here to here. But if we try to understand, if we think in a backward approach, like how can we reach at this particular index, so we can reach this particular index by here and here. Like it is the case when this person will jump to here and this person will jump to here. So these are obviously the only possibilities possible, and the minimum between this the previous value of this particular position plus this value. Okay, and similarly for this particular position previous value and its own value. So between both of them, if this value versus this value, so which will be the minimum one will be stored here. So let's code it, you will understand in a better way. So we are making size cost dot length, and we will be making our dp array. So why I am making it to n+1, since we are required to reach outside the array, so we have to calculate for this index also, one extra index also. So that is the reason. So let's make a for loop from 0 to n. Yes, now what we will be doing is, like if I is equal to 0, one case, else if I is equal to 1, or else case. Let me explain you. Like if you are standing at this particular position, which is this particular position initially, it is obviously 0. Okay, so if you are standing at this particular position initially, like we were given an option to stand at either position 0 or 1, so what will be the minimum possible for this? it will be obviously 0. So yes, it will be 0. So we don't require this thing I got wrong. Yes. So we will just start from second index only, since we are given the choice to stand on either of them and start our journey. So basically the initial cost will be 0. So now dp of I is equal to math.min of basically like dp of I minus 1 plus the cost of I minus 1 versus dp of I minus 2 plus cost of I minus 2. So let me explain you what we have done here. Like if we have to reach up till this index, so let it be 5, let it be 3, let it be 7, let it be 4. So basically 4 and 7 are the previous prices to reach up till this particular index and this particular index. So if we have to reach up till this index, what we will be doing is we will go to its previous index, okay, because it can make a jump here. So we'll go to previous index and ask him, okay, so what is the price of reaching up till you? So it will tell, okay, reaching up till me is 4. So he will tell 4. Now this price will also be included, 4 plus 5. Why? Because now we have to jump here. So yes, our 5 will also be included, so it will be 9. Similarly, when it will go to this index minus 2, basically I minus 2, it will ask, okay, so what is the price of reaching up till you? It will say 7. Okay, if it is 7, then you have to jump till me, so your price will also be included, so it will be 7 plus 3, 10. So which will be the minimum, like 9 versus 10? So 9 will be stored here. Okay, so that's the case. And what we have to return? We have to return basically the dp of n, the last box, which actually does not exist. So let's try to submit it. So yes, it is working. So that is it for this video. So let's analyze the time and space complexity. So the time complexity will be just O of n, since we are making only one for loop and iterating over it, and the space complexity will be also O of n, because we are making a DP array of the same size. So but we can do here much better also, like it can be done in O of 1 space. How can it be done? We need to understand how can we decrease our space. Basically the hindrance is like we just need only previous 2. For any index we just need previous 2. So why do we need to make such a DP array, such a long DP array? We can just make 2 variables and just switch the values in them, like it is given here also. You can refer here, like only 2 variables are taken into count. So yes, you can do like this also. It is easy to understand, you can do that yourself. So that is up in this video. So let's end. Till then, stay tuned, do like and share the video, and don't forget to share your valuable feedback in the comments. And you can also suggest me if you need a video on any particular topic that you like. Till then, bye bye and have a nice day. Thank you.